All right, there we go. Okay, so let's talk about discrete probability distributions. This is kind of going to a little bit of description, but oh, don't you let me down now? Come on. Operating so. Alrighty, guys. So the first thing you want to do, since we are talking about discrete probability distribution here, we need to understand what discrete means, but let's start out by what we mean by a random variable. So the idea here, and they're kind of going back to the idea of taking a coin and flipping it 2 times. Your outcomes come out to be, again, 2 heads, first head, second tail, or the first tail, second head, and then 2 tails. Now, if we are interested in the number of heads, that in this case, we would say if the outcome of a probability experiment is a numerical result, we say that the outcome is a random variable. And what we mean by that is we're saying a random variable is a numerical measure of the outcome of a probability experiment. So its value is determined by chance. And in this case, we would say random variables are typically denoted by using the capital letter X. In our coin flipping example, your X would actually end up representing how many heads did you get when you flipped your coin. So of course you can see you can either have 2 heads, you can have 1 head, which would be that either head on the first, tail on the second, or tail on the first, head on the second, right? But both of them still count as 1 head. Or you could have no heads because your coin landed, both times on a tail. So in this case, when we're talking about a random variable, guys, we're basically saying, okay, we did this probability experiment. What kind of outcomes do we have? And in that case, your outcomes are going to be how many heads did you get when you flip that coin 2 times. So as it shows you here, that means your possible values for X could be 0 heads, which will be coming from this, 1 head, which would be either of these 2, or both of them were heads, which would be that outcome. Okay. Okay, they're just talking about in terms of we normally always use a capital letter X when we're trying to identify the random variable, and you will use actually a lower letter X if you are listing all the possible values of the random variable or the sample space of your experiment. Okay, they're just talking about another example there, and you guys can read that at leisure, but let's break down what a random variable is in terms of discrete or continuous variables. So when we're talking about discrete, guys, we're basically saying it's going to have a finite or a countable number of values. So the values of a discrete random variable can be plotted on a number line with space between each point, and you can kind of see that figure A at the bottom of the page. A continuous random variable, we are saying, has infinitely many values. So the values of a continuous random variable can be plotted on a number line again, but in uninterrupted fashion. So you can see that's a continuous line, whereas with discrete, they are separate points, right? It's not one continuous line. I think the best way to think about that is discrete random variables can be counted because they were talking about the numbers being countable, and continuous being something that comes more from like a measure, right? Something that has to be, I would say basically, I would say think about it as being something that would have decimals, whereas as something being able to be counted with discrete, you can see in the on the left-hand side where it says, in other words, discrete we're talking about as numbers being 0, 1, 2, 3, and that kind of thing, right? Because we're talking about when you plot them on the number line, between each point, you should have some space. Whereas with continuous, as the name suggests, it's, you know, one big continuous line instead of just being numbers with spaces between. Let's take a look here. So again, just to distinguish between discrete and random variables, the number of A's earned in a section of statistics with 15 students enrolled in a discrete random variable will be a discrete random variable because, you know, we can count how many A's students have in class. So none of them got a 15, so our X value could be 0. All of them got a 15, your X value will be 15 or anything in between, right? Depending on how many students in the class ended up getting a 15, sorry, getting an A on their, I guess, class score. Number of cars that traveled through a McDonald's drive-through in the next hour would also be a discrete because you can count how many cars went through the drive-through. Now, this last one, the speed of the next car that passes a state trooper will be considered as a continuous random variable because, of course, speed is measured. If the value S represents your speed, then any possible value that you could have are basically going to be positive numbers because we know speed's going to be positive numbers. And we're saying that will be S greater than 0. Because, and you know, the thing here is what kind of number you will get will actually depend on the measuring device, right? So is the, is that called the radar gun that they use for medical speed, right? So it will depend on, is the radar gun giving you back whole numbers? So like, was your speed 85 or is it giving you like 84.7, right? So that will actually depend on the instrument that's being used to measure. But technically the idea is you can get decimal answers for the speed, right? I mean, I know our odometers normally give us whole numbers, but that's not completely accurate because you could be driving 84.7 miles per hour. So this is a good way to kind of distinguish, you know, how we talk about discrete and random variables. All right, so let's talk about discrete probability distributions. We'll be doing continuous, I think chapter 6 is where we begin with the continuous variables, if I remember correctly. All right, so when we're talking about a probability distribution, guys, remember that is just basically for a discrete random variable X provides the possible values of your random variable and what their corresponding probabilities would look like. So it is basically like a, you know, when we talked about the frequency distribution table, it's going to have that same setup, but instead of frequencies, we're talking probabilities here. So on one side, you will basically have what the random variable value is, and on the other column, you will have what the probability of that outcome coming out to be. So probability distribution can be in the form of table, which is what is mostly preferred, but you can also do it as a graph or a mathematical formula. So just to set that up, take a look at this guy. So we have, let's say we ask a basketball player to shoot 3 free throws. So your, of course, random variable would be the number of shots. So if they make no free throw, of course, that's going to be 3. If they make one of them, 2 of them, or all 3 of them, right? So that would become your value of the number of shots. And then your probability will be based on that. So we denote probabilities using the notation P of X. And you will notice that's a small letter X. So where X is the specific value of the random variable, you would read it as the notation P of X as the probability that the random variable X is going to be, 0, 1, 2, or 3, depending on whatever that small X value is going to be. So here we would say the probability that the basketball player, makes all three shots is going to be 0.51. And you of course read it as the probability that the random variable X equals 3 is 0.5. So some rules when you are working with a discrete probability distribution. Again, the total for all your probabilities has to come up to be 1. So remember, guys, that summation notation is when we use for getting a total for all the, column or row, whatever you're adding. So the total of all the probabilities should come out to 1. Each individual probability for each individual outcomes should be between 0 and 1. It can be 0 or it can be 1, but obviously nothing smaller than 0 and nothing larger than 1. So you will notice these rules are the same from what we did in chapter 5. We're just using it now for probability distributions. And again, look at these examples over here. They're asking you just to identify if we have a discrete probability distribution or not. So obviously the total for our P of X column should come out to be 1. And each individual probability has to be between 0 and. So which ones of these would you say is not a discrete probability distribution? Which one is not a discrete probability? And why? And very good. So even before you do the addition, you will see one of our probabilities were negative. So even if that adds up to 1, it doesn't matter. You cannot have a negative probability in there. What about B? All of our probabilities are between 0 and 1. So that part is okay. But what happens when you add that last column? Does it add up to 1? Yes, no, maybe?
I don't know the answer. I just know that you got all those.
Well, think about this. When we add these three numbers together, 20 plus 25 is 45. 45 plus 10 is 55. That's 55. And this guy is almost close to 50, right? And this is 14. So this is going to go up to larger than 1 when we add. So we know this is not adding up to 1. So he's gone. All of these are between 0 and 1. So those 5 probabilities are okay. But again, what's that total? Yeah. Yeah. So this does add up to a total of 1. So this was the only one that we can say is a discrete probability distribution. So remember, guys, those 2 rules may seem very straightforward, but they are very important. So even as you're going through homework, make sure you're paying attention on those rules. All right, perfect. Let's talk about what a graph of this guy. I think this is just, yeah, see for part B, it's adding up to 1.18, which is larger than 1. So obviously that second guy was not going to work out. All right, this is something you do want to pay attention to. Look at that little paragraph before the example. So they're talking about in a discrete probability distribution, your horizontal axis will represent the values of your discrete random variable. Your vertical axis would represent, those corresponding probabilities. Now, because we know our data is discrete, when you are graphing these discrete probability distribution, guys, you are actually going to be using vertical lines above each value. And of course, the height will be based on, what that probability for your random variable is. So you are going to be using literally vertical lines to draw your graph. So let's take a look at this example. This is table 1 from example 2. So this guy here. So remember, this was that basketball player making three free shots. So the probability that he doesn't even get a single shot was at 0.1. He makes one shot was 0.10, two shots at 0.38, and of course, if he made all three, 0.51. So if you wanted to graph this little table over here, what would that end up looking? Look at when we're talking about what a discrete probability distribution graph is. This is exactly what it is. You're literally just using vertical lines to draw your graphs. So our initial, when he made no throws, remember that was such a small probability because it was 0.01. It almost looks like you're at 0.0. The idea that he makes one shot was at 0.10. So you can see that's the height because that corresponds with that 0.10. And then what do we have for the second one? 3.8? 0.38? Because it looks like it's just shy of the 0.4. And then he makes all three shots, or she, I guess, they didn't really say, was at 0.51. So it's going to be slightly higher than that 0.50. And this is what your discrete probability will look like. Now, unfortunately, in Google Sheets, it really doesn't give us the option of doing these vertical lines. So I just have you guys do column graphs. Because you get the idea of the shape, right? I mean, they may not be lines, but it's going to give you that height, that we're looking for. So we'll just use column graphs to do these graphs in Google Sheets. Because I haven't figured out a way how to do vertical lines. I haven't been able to find that. Okay, I guess we'll stop here. We'll pick up with how to compute the mean for discrete random variables. So this is section 6.1, guys. So as I was saying, for 5.3, your due date will be midnight for Thursday the 19th. And then we'll wrap up with 6.1 and 6.2 hopefully on Thursday. Let's see how far we get. And I do actually have a class activity for us, but we need to finish talking about 6.1 and 6.2 before we can attempt the class activity, okay? So if you have any questions, please say that. I'll be happy to answer. And if not, I will see you guys on Thursday. All right, be careful, guys. Stay safe. Oh, your attendance thing. Okay. And if you guys don't want to stay for this, that's fine. But Vic had asked me if she wanted to make up attendance points. So, you guys don't fall below that 90% thing. So I had told her what I was going to do. So this will be something we didn't get a chance to talk about in class, but you can use that as attendance points. So I think it was under chapter 2, we didn't get a chance to talk about it. So we did do the survey, we did the so it's a chapter 2. Yeah, so it's that average American discussion. We didn't really get a chance to do that. So if you want to make one attendance class that you have missed and you'd like to, you can work on this assignment. So what that would look like is basically you would have to come up with your own idea of who the average American is. So before listening to the podcast, and you will see there's the link for the podcast there, but before listening to the podcast, based on that first bullet point under the instructions, think about what your average American is going to be based on their age, race, gender, married, kids, level of education, how far they have gone, what their household income would be. And what measurement would you use out of mean, median, mode, mid-range? So how would you calculate your average American? Once you have that description written down, guys, then go and listen to the podcast and then compare your answer with what they come up with as the average American. And that would be the second part where you would be talking about, well, I had this, but this is what the podcast said. What was the difference? What were the similarities? And that kind of thing. And then the last part is asking you, just if you had to find the average of anything. Anything that you would be interested in, how many hours do people do something, or, whatever it may be, how much people eat or sleep or drink or whatever you might have. What would you want to find the average of? And again, what measurement? So those three would be the questions you would answer. Put them in a Word document and email them to me. I'll read through it, and if I feel like you did a good job, that gives you your one attendance point back on the attendance. And let's do this. If you need more things you want to make up for, then I can give you another activity, but let's start out with this. So this is going to be under the chapter 3 module, guys, okay? All right, go home. Have a good afternoon, everyone. Take care. Thank you. You have questions?
Just,
For